we've already talked about cross product, but there are some things about cross products that we didn't get into. So the beginning part of the outline here is talking about stuff that we, how do you calculate a cross product? It's going over how to do that. We've talked about if the cross product is 0, then your vectors are parallel. And we've talked about how A cross B is not the same as B cross A. They're actually opposites of each other. Okay, so the one thing I know we did not define was this computation called the scalar triple. And the scalar triple is you get the same value whether you pick 2 vectors or another pair of vectors. So if I pick B and C, so I have 3 vectors. A is a vector, B is a vector, C is a vector. So if I cross B and C, that will give me another vector that's actually perpendicular to both B and C. We talked about that too. If I then dot that with A, the dot product is a number, it's a scalar. I will get the same number whether I cross A with B and dot it with C, and then you could also cross A and C and dot it with B. You'll get the same number no matter what order you pick to cross and then dot. That number, taken as a positive, okay, so I mean a lot of times you're going to get a positive and you could possibly get a negative value. If you take the absolute value of it, that number is the volume of the box that gets formed by the 3 vectors. Because the vectors won't necessarily be at 90 degrees, I said box, if the angles are not 90 degrees, then it forms a box that we call a parallelepiped. So we picture a box that you're kind of smushed so that, the sides of it are not at 90 degrees. Okay, so I want to practice finding the scalar triple and kind of visualizing how it's the volume of a box formed by some vectors. So in our packet we have some so if you flip through your packet, there's a problem number 12 that I want to do. Okay, so I have 3 vectors here, and the 3 vectors are 6, 3, -1, 0, 1, 2, 4, -2, 5. So 0, 1, 2 is probably that one, and then the green one. So the red one is probably the first one, and the blue one is the second one, and the green one is the third one. Or are there any more little packets out there so I don't have to...
Right here?
Yeah, there should be 2 of them because I ran off 18 and I and Claire were 6 today. So this vector is 6, 3, -1. This vector is the 0, 1, 2. And this vector, the green one, is 4, -2, 5. That's this vector, that's this vector. Okay, so they're scalar triples, so just pick 2 of them and cross them. So I'm going to cross the 4, -2, 5 with the 0, 1, 2. So we're going to find the cross product of the 2 shorter vectors. So remember, when you're finding the cross product, it's a vector itself, and so it has an x or an I component. The coefficient of it, or the component of, in the x direction, you ignore x, you take this y multiplied by that z, so I'll get -4, and then I subtract this z multiplied by that y, so that's going to give me -9 for the component in the x direction. Then for the y, you take the opposite, and so 4 times 2 is 8, minus 0, so 8 minus 0 is the j, but you take the opposite of it, so it's -8. And then for k, you block out the k and take x times y, and then you subtract these two, but it'll be 0 again, so plus 4k. Okay, so that's the cross product of those two other vectors. If I then dot that with 6, 3, minus 1, if I dot those two, I'll get -54 minus 24 minus 4. So we get 78 minus 4 more is 82, -82. Okay, the volume of the box that I would create if I like extended A out from here and another A out from here and then connected these two and connected those two, and you formed a box with your 3 vectors, the volume of that box is 82. And you will get the same value no matter what pairing you make. So, for example, if I chose to dot the 4, -2, 5 with the 6, 3, -1, we would get 2 minus 15, -4 minus 30, 12 plus 12, you're always subtracting, so we get -13i plus 34j plus 24k. Then dot that with the 0, 1, 2. So 0 plus 34 plus 48 is 70 plus 12 is 82. So notice my scalar projection here, I got positive. Again, the order that you're crossing changes the direction here, and so that will change this. But the volume ends up being 2, whether I picked the 2 that I originally did to cross, or whether I picked these 2 to cross. If I picked the other pairing to cross, again, we'd still get 82. Maybe we get -82, but the volume would then be okay, so again, that's called the scalar triple. I'm sure in physics it has some other uses too, but a geometric use is that it's the volume of the box that's created with your 3 vectors.